Hi, my name is Frank Acosta from AA Dental Design. I have a laboratory in Marietta, California. Our laboratory tries to add every year new products. So we spend the year before usually, testing out, certain materials to see if they fit our workflows. When we choose a material to incorporate into our laboratory or add it to our workflows, normally it's because it helps us cut time on our processes and stuff. Another thing that we also look for is again the quality of the material. Our laboratory believes in a digital workflow. With that being said, 95% of our cases that come into our lab are digital impressions. We normally give a 5-day turnaround time on most of our restorations. But because our workflows are so streamlined, we also give the option of 4 working days, 3 working days, 2 working days, and 1 working day, or I'm sorry, 1 working day, or a same day case. So we decide whether or not we want to mill the restorations in a block, or we want to mill it in wax, invest it, and then press it. But that will be determined by how fast the restoration needs to be delivered. When we first started using Celtra, it was Celtra Duo. It was the block form of Celtra. Since we do same day cases or also go out to offices and do chairside dentistry, we started to incorporate the Celtra instead of other materials to see how the workflow was. So we were able to cut some time down because we were able to polish it. And if we wanted to polish it, we would still have the strength, not as strong as if it was glazed, but we were able to do cases a lot faster and maintain the quality that the doctor expected and also the patient. When we started looking at pressing at the lab, one of the reasons why we started looking at that was because we noticed that, we were processing our cases pretty fast, especially if we were milling out blocks. But we kind of started doing numbers, and we started noticing that if we started getting a lot of posterior crowns, our material costs would go up. So we started looking into pressing to see if we can bring down the cost. Adding this process to our workflow gave us some new issues. We started getting, sometimes we would have mispresses. We would find ourselves having to remill things to then reinvest to then press them. We weren't used to it because everything that was being done at the laboratory was all being milled in blocks. At the end, we just wanted this workflow to work. So the beginning of this year, I hired a tech that specialized in pressing at the other lab that he worked at. That's all he did was press. So I brought him in. I looked at Celtra and I gave it to him, and I told him, look, this is what I want to use. Use it for about a month, and then get back to me and tell me what you find, what you like, what you don't like about it. So then we incorporated it for at least a month. One of the first things he said to me was, I love this product because after you press and you devest, there's no reaction layer. Second thing he said to me was that he liked the way it flowed. The way he was spruing, he did a 3-unit bridge, and we saw this picture where the sprue was coming from the side. So we, and later in a little bit with this presentation, you'll see what I'm talking about, where he saw a sprue coming through the contact of a 3-unit bridge. So he tried it out, and he was able to succeed. He was able to actually press it, and it worked out great. When he told me that, to be honest with you, all I was thinking about is, how many cases can we bust out, without having any kind of issues? And also, if we needed to scale this, how easy would it be to train somebody to invest, to sprue, to be able to just, continue growing our laboratory and also using this workflow to make things a lot easier. So at the end, we decided that we were going to incorporate Celtra into our laboratory, with our advertisement, and also, try to grow that restoration into becoming one of our main restorations that we produce at our lab. With that being said, let's get into this PowerPoint that I have, so that way we can talk about what Celtra is. So the Celtra system was actually launched in 2013. It was known as Celtra Duo. It was used in the dental offices and also in the dental laboratory. In 2016, they came out with Celtra Press, also added, Celtra Ceram, Celtra Investment, and it's mainly for laboratories. Here's some differences between Celtra Press versus Celtra Duo. Of course, Celtra Press is for all indications, including digital workflows or analog workflows. And with Celtra Duo, you can't do bridges at this moment. And also, of course, you can't wax it because it's milled with a block. So all you old school techs out there that like to hand wax, you can't use Celtra Duo. So come join us on the milling side. So here you have the composition comparisons between Celtra Duo and Celtra Press. You can see that they're very similar. A couple things changed. Lithium oxide 14.8 compared to 18.5. So those are the big differences that you can see. Let's get a little bit into the product summary. The pellets come in HT, MT, LT, and then the shades vary between which pellets you buy. Also, the pellets come in small and large, 3 grams and 6 grams. They come in a 5-pack for the 3 gram and a 3-pack for the 6 gram. What's cool about this Ceram porcelain system, it can be used for Celtra Press, lithium disilicate, zircon HT, zircon XT, and for those of us that know that that's what we use, a lot of us in the in-lab community, we use the zircon HT and the zircon XT. We can definitely use the Ceram porcelain for that, and of course with the zirconias as well. Sorry. Again, pretty cool stuff here. We can use it for inlays, onlays, partial crowns, tabletops, veneers, implant substructures, anterior region, and for the bridges, 3-unit bridges until the second premolar. Again, we can use it for many indications. Again, sorry. I think I'm just getting too old for this. I lose my voice very quickly these days. So moving forward, when it comes to the Celtra Ceram, we have our dentin, enamel. We also have add-ons. These cannot be used with the Celtra Duo. It can only be used with the Celtra Press. For the dent supply people that are listening, we need these for Celtra Duo pronto. With the Celtra Ceram, it comes in different kits. You can get the basic kit, the aesthetic kit, or the gingiva kit. And just if you want to just try things out, they have the trial kit for you too. For staining, they come with the universal staining system. It has the 14 intensive stains, 5 body stains, 2 incisal stains, and 2 overglazes. It comes with the high flow and the standard as well. So that's also in a kit. You can order that to get things rolling. When it comes to the system, just get the press investment. Also is available. Also available is the Celtra Press Wax. As for the accessories, you can get 2 different size rings, the 100 gram or the 200 gram. You can get the plungers. I wish I knew what that little pad thing was called, but you can put your ceramics after you glaze them. It's just a little pad that you can put into the, and sorry, I don't remember what it's called, but you can get one of those as well. You put your crowns on it and then put it into the oven when you're glazing or adding porcelain to it. I just found out the other day that they have a finishing and polishing instrument kit. I haven't tried it, but I placed my order. So as soon as I get some feedback on the instruments, I'll definitely let you know. And lastly, they have a self-adhesive cement called Calibra. Again, I'm not a dentist, so I've never tried this, but that's what I've recommended to the doctors that I send out the Celtras to. Okay, so let's talk a little bit about the workflow, how everything kind of works. So when it comes to the preps, of course, docs, give us some clearances, give us what we need. We can't give you crowns that don't look nice if you don't give us the clearances. Best of all, 0.4 on the veneers. Sweet. As we were talking before, conventional wax ups, or my favorite way of doing things with the CAD/CAM system. Everything in our laboratory, like I said, we don't really have waxers, so we just mill all our wax with the in-lab system. You can scan with the INEOS X5. Once you scan, you can design it. After you design it with the in-lab 16.1, you put everything into pucks or wax pucks, and then you just mill it out. We then sprue them. Again, you have your selected rings of 100 grams or 200 grams. Your sprue diameter should be anywhere between 2.5 and 3.5. But what's really cool is that whole bridge situation here, where we can actually put one sprue on the 3-unit bridge and it will press. It will press really nice. I couldn't believe it, but it actually worked. So then, when it comes to your ratios, your mixing ratios, 100 grams, powder to liquid, 222 milliliters, manual pre-mixing, 30 seconds, mixing time under vacuum, 60 seconds, working time, 4.5 to 9 minutes. You then use the top ring former to ensure the correct ring height, and then the setting time is the speed would be 20 minutes, and then the standard would be 30 to 40. All right, so with the burnout and the preheating, you know what? I would read all of this, but I'm sure you guys can all see the screen. So you guys take a couple minutes of your time, or a couple seconds, depending on how fast you read, and kind of take a look at all this stuff right here. All right, so for the ingot mappings, for the HTs, you're going to use inlays. You're going to use it for inlays, onlays, and veneers. They come with I1, I2s, and then I3 shades. So then for your fully contoured crowns, your MTs, comes A1, A2, A3, B1, C1, D2, and then you stain and glaze, usually for posteriors. All right, so finally for your cutbacks, you're going to use the LT, which come in BL2, A1, A2, A3, B1, C1, and D2. And usually those are for your anterior work. Okay, so for your pellet selection, up to 0.7 grams of wax weight, you can use one pellet, 3 grams. You can use that in a 100 gram ring or a 200. So then up to 1.7 grams of wax weight, one pellet of the 6 gram, and you can only use it in the 200 gram ring. All right, so for your pressing parameters, like I said, you can just take a picture of this, or you can also see this online when you go to dentsupplyserona.com. But avoid long waiting times between removing and investing ring from the burnout, preheating the furnace, and placing it in the pressing furnace to prevent excessive cooling of the ring. Okay, so just make sure that you don't have one oven and the other one too far away from each other. We have ours right next to each other. All right. After we press, we devest. Sandblast it. Okay, so then, remove under irrigation, diamond disc, grind with diamond adhesives, apply minimal pressures. Okay. Well, now I know what that little box was called earlier. It's a firing pad. All right, so this is important because, and of course I'll read it. It is important to use only ceramic or investment type pins. Alternatively, the object can be placed directly on the firing pad. Other firing pins, such as pins made of metal, will not facilitate a proper heat transfer and will create a stress joint, a stress point that may lead to cracking. The key point here is that it will lead to cracking because we've done it and it has cracked. In the beginning, we would treat it like an Emax. We would put putty inside, make sure that our margins were protected, and then the next thing we know, when they were coming out of the oven, they would break. They would come out cracked. To be honest with you, this material is not Emax, and it should not be treated like Emax. Okay, so here's your firing recommendations. They have something that you have to do, which is called a power firing. If you're going to start your ceramic layering, so that basically goes first. On the bottom, again, just kind of read it out loud a little bit. Power firing, because I could say it in my own words, but I'm sure it sounds better when I read it. So power fire is a firing program that is carried out before the first firing of the veneering ceramic layer. Okay, so you can kind of read the rest, but the most important part is, avoid sandblasting after power fire, as this would reduce the bending strength of the restoration. So once you do that, it builds up the strength to 500 megapascals, and then you continue on Denton 1, Denton 2, and then glazing. So there's your fire recommendations for that. And then for your fully contoured restorations. Okay, you can get most of this information again online. They've revamped their website. They have a lot of information on there. Temperatures, if you want to know about the in-lab system, they have a lot. Their new website, and Supply Serrano's new website, is really, really informative. So if you haven't checked it out, definitely go on there and check it out. But you can get all these temperatures on there as well. Okay, so finally, I just want to end the webinar with a couple things that we do at our laboratory. Again, in our laboratory, we don't hand wax anything. Everything is milled out with the in-lab system. We design, we send to CAM, we mill with the X5s, the MCX5s. Everything is milled out in wax. We cut it. We check them on our little dies that we print out and stuff like that. Or we just invest them and press them. Going back on when we were talking about how to process it when you're glazing, you can notice on the first picture we put some putty in there, tried to protect the margins. Next thing we know, when it came out of the glaze, it was cracked. On the other one, all we really did was put like a little mount so it would hold it, but we would use that pad. And once we put it there, we had great success, and we did not have any kind of cracks. So definitely don't treat it like an Emax. It's not an Emax. Just make sure that you follow the directions on the processing of the actual Celtra after it comes out of the oven. And then lastly, this was something that was actually pretty cool. I have a doctor that's a CEREC doctor that really loves Celtra, and he even has me do custom abutments made out of Celtra. So he scans them out with his CEREC, sends it over to us. We design it, we mill it out in wax. Once we mill it out, we invest it, and they come out really nice. And those little notches on those Serrano tie bases are really, really small, and they come out beautifully. So the flow of this material is pretty impressive when it comes to being able to do thin press veneers or cases like this. So okay, so once again, thank you for taking the time to watch this webinar. I know being in the lab life, I know how hard it is to just kind of stop what you're doing for a little bit and just listen to me with my losing of my voice and me stuttering every once in a while. So again, thank you very much. It is an honor to present these to you. But if you have any questions, let me know.